is it true that the difference between any set and the empty set is just going to give you that any set? And that should make sense. This is sort of like, this is akin to saying something like 1 minus 0 or x minus 0 or pi minus 0, whatever. These are all just going to equal to the original thing before subtracting 0, right? That's basically what we're arguing here, and that seems to make sense, right? If a had, let's say, 1 in it and 2, minus nothing is still going to give you 1 and 2. If it just had 1 minus nothing, it'll still just be 1. If it had 1 dot 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 and a whole bunch of like other elements, it would still just be 1 dot 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 and a whole bunch of elements, even though you subtracted nothing from there. And even if a was empty, right? Empty set minus the empty set, nothing minus nothing still leaves you with nothing. So it looks like this is definitely going to be true. So let's go ahead and think about how we're going to prove this. So this is an equivalence statement, which means we have to prove that, we need to prove that a minus the empty set is a subset of a, and we have to prove that a is a subset of a minus the empty set. We have to prove both of these to be true in order to claim the statement is true. So let's do that. So to start off, we have to use a let, because this is a for all proof. We're looking at any set A, so it's for all sets A. So we say let A be a set. Remember, we don't need to suppose the empty set is a set. That's a given. That's like saying 1 is a number. You don't need to say that in math, because when someone's reading your proofs, you're going to assume they know that 1 is a number. But when you're using something ambiguous like A, you need to be clear whether that's a set, whether that's a variable, whether it's a matrix, whatever you want it to be, right? So we're going to say it's set. Then we're going to go into our first case, proving the left-hand side is a subset of the right-hand side. So to prove that A minus the empty set is a subset of A, we need to show that any element x in the set A minus the empty set is also going to be in A, right? We have to show that any element here is going to be an element here. Okay, so let's maybe break apart what this means up here. So this means that obviously x must be in A and x must not be in the empty set. And this makes sense, right? X has to be in A and x cannot be in the empty set. That's what the difference means. And this part makes sense because you can't have anything in the empty set. So this is true. X is not in the empty set because you can't have anything in the empty set. So this means that obviously x is going to be an A. Yeah, that should work. Okay, that should be more than enough for our proof. That seems fairly straightforward, so let's go ahead and write that down. So we'll start by supposing our x. So we're going to say, suppose x is an element of A minus the empty set. And then we want to say that then, that obviously means x is an element of A, and x is not an element of the empty set. And now we can say that since x is an element of A, then of course A minus the empty set is going to be a subset of A. We've shown that any element here is going to be here, which makes this a subset of that. Fantastic. All right, let's try our second case now. So to show that A is a subset of A minus the empty set, we have to show that any variable y in A is also going to appear here, right? If y represents all the variables or all the elements in A, then if we can show that y is in here, then all the elements here can be in here, which makes this a subset of that. Okay, so y being an element of A, then I think you can just actually immediately jump to here, right? Like, this obviously means that since y is an A, then y has to be an A minus the empty set, since A minus the empty set inherently implies y must be an A and not in the empty set. So that seems fairly trivial. I'm not sure how to word it perfectly, but we'll give it a shot. So let's start by supposing we have a y. So we say, suppose y is an element of A, then I think you can just immediately say then y is an element of A minus the empty set by definition of the difference between two sets meaning y is an element of A, and y is not an element of the empty set. So I think that's enough. I don't even think I need to write this down. I could have put a full stop there. Okay, fantastic. I think you get the point of the logic here. So now I guess we could just, oh yeah, we need to conclude that. Therefore, A is a subset of A minus the empty set. Fantastic. Okay, now we can conclude that since this is true and that's true, this is true. So we can say, in conclusion, since A minus, I want to say theta. I keep trying to say theta because physics, but it's the empty set. If A minus the empty set is a subset of A, and A is a subset of A minus the empty set, then A minus the empty set is equal to, is equal to A. Yeah, I think that makes sense. Okay, so we seem to have gotten it. This seems to prove the statement is true. Fantastic.